Welcome to Domain Driven System Part 1. In this session, we will be diving deep into one of the most powerful software design methodologies, Domain Driven Design or DDD. This approach enables developers to create systems that are not only functional but also maintainable, scalable, and aligned with the real world domain they aim to represent. Over the next few slides, we will explore the key concepts and building blocks of DDD, setting a solid foundation for more advanced topics in future sessions. Let's get started. Domain-driven design is an approach that prioritizes collaboration between developers and domain experts in order to design software that truly reflects the business domain it serves. The key to DDD is aligning software models with the real-world problems they aim to solve. Unlike traditional methods, where the focus is mainly on technical implementation, DDD stresses understanding the problem domain deeply and ensuring that the design evolves based on this understanding. It provides a framework to design software that is not only technical sound but also aligned with business goals, leading to better outcomes for both developers and stakeholders. At its essence, domain-driven design connects the software design to the business domain. The main goal of DDT is to bridge the gap between the complexities of business requirements and the technical aspects of software development. This means that rather than focusing on the technical details first, DDD encourages you to explore the business domain and model the software around it. By modeling the software in this way, it becomes easier to evolve and adapt as business needs change, and the developers can more easily collaborate with domain experts to ensure a better alignment with real-world requirements. Why should you care about domain-driven design? In large and complex systems, business logic often becomes tangled within the software code. As systems grow, these complexities become harder to manage, leading to more errors, slowing development cycles, and higher costs. DDD helps solve these problems by providing a clear set of principles to guide the design process. By emphasizing a close connection between the business domain and software architecture, DDD ensures that the software evolves in a way that directly supports the core business needs, keeping the system agile, maintainable, and aligned with business objectives. Essentially, DDD provides a structured way of designing software that can handle complexity and change effectively. Now let's dive into the building blocks of domain-driven design. These are the key concepts and elements that help structure a DDD-based system. The main building blocks include entities, value objects, aggregates, repositories, services, and factories. Each of these plays a critical role in helping us model the business domain in a way that's meaningful, understandable, and flexible. We will take a closer look at each of these components, and by the end of this session, you will be able to recognize how they fit together to create a solid domain-driven architecture. Let's start with entities and value objects. These are foundational concepts in DDD. Entities are objects that have a distinct identity, which means they can be tracked and persisted over time. They have a life cycle and their identity remains consistent even if other attributes change. For instance, consider an order entity in an e-commerce system. The order has an ID that uniquely identifies it throughout its life cycle. On the other hand, value objects are different. They don't have a distinct identity and are defined by their attributes. A value object is mutable, meaning once created, it cannot be changed. Think of an address object or a money object. They are just a collection of values, and their equality is determined by comparing these values. They don't change over time, and their role is to provide detailed information that helps define entities in a meaningful way. Next, we have aggregates and repositories. Aggregates are groups of related entities and value objects that are treated as a single unit. An aggregate is always accessed through its root, called the aggregate root. The aggregate ensures that the entire cluster of objects inside it remains in a consistent state. For example, in an e-commerce system, an order could be an aggregate that contains several order items as well as other related value objects like shipping address. Now to access these aggregates and perform CRUD operations, we use repositories. A repository provides methods to store, retrieve, and search aggregates. Repositories serve as the interface between the domain model and the database, ensuring that the business logic is decoupled from the persistence logic. Now let's explore services and factories. A service is a domain operation that does not necessarily belong to any one entity or value object. It's a piece of logic that spans multiple entities and performs a business operation. For example, in a banking system, a transfer service might handle transferring funds between accounts. It encapsulates business logic that needs to interact with multiple aggregates or entities. On the other hand, factories are used to create complex aggregates or entities. A factory takes care of the creation process, especially when an entity or aggregate requires some initialization logic before it can be used. For instance, if we are creating an order, the factory might handle the process of initializing the order with the required details and validating business rules before it can be stored in the repository. A key concept in DDD is the idea of shared language, also known as ubiquitous language. This is a language that both developers and domain experts use to describe the domain model. The goal of having a shared language is to reduce misunderstandings and ensure that everyone is on the same page when discussing the system. By using common terms to describe domain concepts, the risk of miscommunication between developers and domain experts is minimized. This leads to a more accurate understanding of the system, ensuring that the software is aligned with business objectives. The shared language is an integral part of the DDD process as it becomes the foundation for both communication and design. Let's consider a real-world example to see how these concepts come together. Imagine we are designing an e-commerce system. In this system, we might have entities like order and product. These are entities because they have distinct identities that persist over time. We could also have value objects like address and money that are immutable and define essential attributes for our orders. We would have a payment service to handle the payment processing logic and repositories like order repository and product repository to handle persistence. By applying DDD principles, we can create a model that reflects the real business processes in the e-commerce domain, leading to a more maintainable and scalable system. To recap, today we have covered the essential building blocks of domain-driven entities, value objects, aggregates, repositories, services, and factories. Each of these elements help us model complex domains in a structured and meaningful way. By the end of this session, you should have a solid understanding of how these components work together to form a cohesive domain model. In the next session, we will delve deeper into more advanced DDD concepts such as bounded concepts and context mapping, which are essential for handling the complexity of large systems. For your practice exercise, I recommend choosing a domain that you are familiar with, such as a library system, a ticketing system, or even a banking system, and start defining the entities, value objects, and services in that domain. Try grouping related entities into aggregates and identify how they interact. Once you have modeled your domain, think about how you would create repositories to manage the persistence of these aggregates. This will help reinforce the concepts we have discussed today and get you hands-on with applying DDD principles. Thank you for your attention.